All right, so for today's class, we're going to jump ahead now. We went back to look at equations, but we're going to go and look at understanding measurements of angles within a circle, and that's standard 8G1. And I'll be successful when I can measure and draw angles. That's our learning intention for today. We just went over 2 questions from Monday's worksheet. So now we're going to review some angles, and then we'll head over to Desmos to look at some of the things that they have on there. All right, so we're gonna start, and we're gonna start by watching this video of this guy going through Ninja Warrior. I don't know if you guys watched this on television, but it's kind of cool.
With the fast time, this is often the cutoff point if you want to make it to Vegas. Now we're gonna try the captain's wheel. This takes so much skill, so much rhythm on captain's wheel. Degrees, you gotta turn that baby. And he's 140 pounds, good light and lean. He's getting close. Oh my! Oh, showed off the strength a little bit. Trying to get a little rest. When you can dead hang like that, that shows up you're very comfortable with your.
All right, so that shows that he had to spin that circle several times. He had to spin that circle several times for him to get to the next part. So that the questionnaire, what information would be useful to figure out? How do you think would be able to figure out how many times he spun the circle? What information do you think we could use to figure out how many times he spun that circle? All right. Let's go here. If we're looking at the video, then we could slow it down a little bit just to see how many times he had to spin, but also how many points, how many stickies, the things that are stuck out, how many of those are on the circle. All right. If we figure out a way to figure out, like count how many of those sticks that are sticking out on the circle, then we would be able to go through and figure out a measurement. All right, but we're gonna get through to the measurement. Someone said you could slow down the video so you could see. Yes, that's absolutely correct. So let's go to our next slide, and we'll be able to slow it down a little bit, but also see a different part of it. So we're going to switch over to this video, and we're going to take a look at it one more time.
With the fast time, this is often the cutoff point if you want to make it to Vegas. Now we're gonna try the captain's wheel. This takes so much skill, so much rhythm on captain's wheel. 145 degrees, you gotta turn that baby. And he's 140 pounds, good light and lean.
See, they said he had to turn it 145 degrees.
He's getting close. Oh my! Oh, showed off the strength a little bit. Trying to get a little rest. When you can dead hang like that, that shows up you're very comfortable with your with the fast.
Cool. So with this one, they showed that the guy had to spin it 145 degrees. All right. In order to figure out how many angles were a part of that degrees, then we'd have to go in and count. However, let's look at this. I have 3 pictures here, and it explains what central angle is and what's not a central angle. So from looking at these pictures, what do you think it means for something to be a central angle? All right, what do you think it means for something to be a central angle looking at these 3 pictures and the examples and the angles that they have drawn? All right, we see some answers saying that it's acute, it's obtuse, but what we're looking for, a central angle starts from the center. That's it. A central angle starts from the center. All right, so we talk about central angles. If you look at these 2, you realize that they're in the middle. All right, and then they open up to form an angle. But this one, the angle starts from the side. So that doesn't classify as a central angle because for the fact that it doesn't start from the center. So let's move over to this slide right here, and we're gonna do central angle measurement. You should see it pop up on your screen, but with this question, we are trying to find the measure of this central angle, all right? If you realize they were marked with dots, okay? So we know that the whole thing is 360. Now let's look at how many spaces are covered for this angle? 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are 8 spaces covered for this angle. 1, 2, 3, 4, 5, 6, 7, 8. Now let's count how many spaces are not covered by the angle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in total, there are 24. Did I say 60? So in total, there are 24 spaces covered, okay? And since there are 24 spaces covered, right, it means that each space represents 15. Okay, so since each space represents 15, and there are 8 spaces covered by this angle, so I have to do 8 times 15. So our angle is 120. And again, if we had the protractor, we would use our protractor, we'd put it on there, and then we'd realize that it's 120. But each space represents 15. And since each space represents 15, right, then it means that it's 15 plus 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 15. When you add all that up, or if you do 8 times 15, then you'd get 120. So the angle that's being covered with this one is 120. So here you'll see that the red arc represents 120. All right, and the red arc is called an intercepted arc. All right, that's just outside the arc. What do you notice about the measure of the arc? The measure of the arc is the same as what the angle is inside because it covers that region. All right, so the angle for this is 120. Okay, because that's what the arc covers. That's what the angle spans to. So your answer is 120. Let's do this one. So we remember we said that each space covers 15, right? And there are 1, 2, 3, 4 spaces. So remember we said each space represents 15. All right. So if we have 4 spaces, what's the measure of this angle? What would the measure be of this angle? And again, if we had a protractor, we'd just put our protractor on there and measure it out. But we know that the whole circle is 360. Each space is 15. And we have 4 spaces covered by the angle. So what would be the measure of this angle? Yes, I see people put it in 60. It would be 60 because each is 15. And then I have to do 15 times 4, which makes it 60. All right, so let's go over to, yes, 16 times 4. 16 times 4, that's what, 15 times 4, sorry, and that gives you 60. So let's go over here and we'll tackle this question in class. But let's go ahead and